Now, more chain rule where we've got product and quotient rule going on. So if I rewrite this one, it's x cubed times cosine of x all cubed. So perhaps that can help you to identify which is where the chain rule is going to be. But first off, the most outside operation that's happening is the product. So first, d second, again, I'm just going to carry that along. Then I'm going to multiply by the derivative of the cosine, which is negative sine. You must put parentheses. A dot is not sufficient. Plus second, well, let me fix that. Second, and I'm going to rewrite it as just cosine cubed of x, and then derivative of the x cubed, which is 3x squared. This one, the most outside operation happening is the quotient. So let's start off with the quotient rule. So I have low plus e to the x squared and d high. Okay, so moving in to take the derivative of tangent is secant squared, carry the angle along, and then multiply by the derivative of that angle. Taking the derivative of 4 is 0, so that's all. This one in particular doesn't need parentheses. Many times you do need parentheses. Minus high, just carrying all of this along, d low. So the derivative of x cubed is 3x squared, and then taking the derivative of e to the x squared, the derivative of e to the stuff is e to the stuff times the derivative of stuff, and this does need parentheses. Oh. All right, there's the parentheses, there's the 2x. All over, don't forget that, x cubed plus e to the x squared, all squared, and never ever multiply the denominator out, correct? Okay, here we go. So 3 layers can happen. So with 2 layers, you take the derivative of the outside, carry the inside along, derivative of the inside. With 3 layers, you're going to take the derivative of the most outside, carry the inside along, and then take the derivative of the next layer, carry the inside along, and then finally multiply by the derivative of the most inside. So you'll know you're done when you don't carry an inside along any longer. Here we go. So one derivative here. Derivative of the tangent first. That's secant squared. Carry the inside along. Then we're going to take the derivative of the cosine, which is negative sine. Carry the angle along. And then take the derivative of x to the 4th, which is 4x cubed. Okay, here we go. So take the derivative here. The most outside function is this 3. So I'm going to rewrite it like this. Carry the inside along. The derivative of cotangent is negative cosecant squared. Got to put parentheses. Carry the angle along and then multiply by the derivative of the inside, e to the x. Okay, this one, you could rewrite it to the 1/2 power. I'm just going to see it this time. So I'm going to bring the 1/2 to the negative 1/2 power. Carry the inside along. Then take the derivative of secant. Whoops, I need another parentheses here. Yep. Take the derivative of secant, which is secant tangent. Carry the angle along. And then multiply finally times the derivative of cotangent, which is negative cosecant squared. Negative, cosecant squared of x. Sorry, that got kind of messy. Okay, so let's go looking at derivative of e to the stuff again. So now we're going to have layers to it. So to take the derivative of e to the stuff, it's e to the stuff. And then times the derivative of stuff. Derivative of cotangent is negative cosecant squared. Carry the angle along and multiply by the derivative of the angle. This one I'm going to take the time to rewrite because this has got that tricky 1 over x. So this is like saying x to the negative 1. So now to take the derivative, I have first d second. The derivative of e to the stuff is e to the stuff times the derivative of stuff, and then plus e to the x to the negative 1 times 1. This one here has got product rule up in the exponent, but we can do this. Okay, so the derivative of e to the stuff is e to the stuff. Now you see the product rule, so it's first d second plus second d first, and all of that needs parentheses. This one has a chain rule up in the exponent there for us when we take the derivative. So derivative of e to the stuff is e to the stuff, and I'm going to choose to rewrite it like that first. Now I'm going to take the derivative of stuff, carry that along. Now finally I'm going to take the derivative of tangent, which is secant squared. Again, going over the derivative of a to the stuff. So again, if you had just f of x is equal to 4 to the x, the derivative is 4 to the x times ln of 4. It matters if it's got more to it, right? So just do a quick, easy example, because this is kind of a new one. So if it was 3 to the sine of x, the derivative would be 3 to the sine of x, ln of 3 times the derivative of sine, which is cosine. So now let's do quotient rule and product rule with this. So taking one derivative, I get low, that's a 3, d high. So 3 to the x squared ln of 3 times 2x minus high, and then d low. So that would just be 3x squared all over the denominator squared. And remember, you never multiply the denominator out. And I'm going to stop there.